Hello and welcome to my YouTube channel. So today we want to look at typecasting. So what is typecasting and how do we do typecasting in Python? So typecasting is basically we're moving from one data type to the other data type in the language. So just remember those primitive types that we had before. Remember we have our list type, we have our text type, numeric types. So how do we move from these categories of data type, moving from one specific one to the other? So like a float to a string, string to float, and so on. Okay, so let's look at that in the compiler here. So online Java compiler here. Okay. Oh, not Java, Python. Okay. Okay, let's run this here. Okay, that runs. Okay, so let's look at typecasting in Python. Okay. All right. So the first thing is what are the previous data types? So there are two categories of typecasting, by the way. Here it says three, but two main ones. So you have implicit typecasting and explicit typecasting. So implicit, this is usually done automatically by the compiler, while explicit is you're explicitly stating to the compiler, this is the type I want you to convert to. Okay, so let's look at implicit. So here, for example, the numeric types, right? So the complex has a higher order of preference. The float is next in line, the int, and then the bool. So that's implicit typecasting or type coercion. Okay. So if you have, let's say you have this function, right? You have two types, complex and a float, and you need to do a result. That type, if you do an addition operation, the type will convert to complex versus a float because the complex has a higher order of preference here than the float. So these typecasting let us know when we do different algorithms and do different operation, what the type is going to be when we carry out these operation based on these default order of preference set by the interpreter. Okay, so let's say here, for example, we have this complex, so we could say let's call this my underscore complex, my complex type equal 20 plus 7j. Okay. All right. And then the next one, we have this float. So my float, okay, equals 20.22. Okay. And then the next one, we have an integer int, my int, right? My underscore int equals 300. Okay. So we have this result will be a complex result, right? So addition, so add, let's call this add result, okay? And we're expecting it to be complex, okay? So if we do my underscore int plus my underscore float plus my underscore complex type. I'll remove the type here for consistency here. Okay. We should get the result to be complex. So if we do a print and we print the result, so add, so this addition result, which we're expecting to be complex, and do the type function here and put that same add underscore result underscore complex, we'll see the type as well as the result. Okay, so it added the 20.22, that's 40.22 plus the 300, and it kept the imaginary number, and it gives you a complex result. So it's not float, it's not an int. The complex has a higher order of preference over a float or an int. So let's say we remove this complex here, okay, and remove this one here. Let me calm it down instead here. So just to show this order of preference here, okay. Our expected value will be now a float, right? Because this float has a higher order of implicit typecasting preference than the integer value, okay? So if we do a my int plus my my result float, we're expecting a floating result here, okay? Okay, and that's the float, okay? So if you see here, class is float, okay? What about Boolean, right? So if we have a Boolean, bool, let's call this my bool, and we set it equal to true, okay? Let's see if we add this Boolean. Let's see if we could add the Boolean, okay? So my, because that's a data type, right? That's a data type. So my bool, let's see what happens here. Okay, my bool here. Let's remove my result. We're not sure. Let's remove the float from my result because we're not sure what the output is going to be. I mean, it should be a float, right? Because again, float is higher than integer and Boolean, okay? So now we could see what the result is, and it says float, okay? So let's remove these two here and let's add my Boolean twice and see what the result is. Okay, because that's a possibility, okay? If you notice here, if you add a Boolean in Python, and it's true, it converts it to a integer 1, and it does an addition, and those two ones here becomes 2. Now it prints and it typecasts the Boolean to a integer. Right, so that's implicit, right? It implicitly converts Boolean when you do an addition to a integer value. Okay, so that's adding Boolean values. Will you need it? Maybe, maybe not. Okay. Okay, so let's see. What about adding strings? What if I have this string here, my underscore string equal, and I set it to a string value with 4 in there, right? It's not a integer, it's actually a string. So let's try adding my string. Will it do a concatenation or will it convert it to an integer value? Okay, so if you try to do a my string here, right, it sends an error saying unsupported operand type int and string. So you're trying to add the Boolean, which really converted to an int, and this string here. So to change this string to a int, we'll have to move to the next category of typecasting known as explicit typecasting. So you can see the type error here. So I'd have to explicitly tell the Python interpreter that I needed to convert to a int. So by doing that, I have to wrap this string into the int wrapper there. Okay. Now it adds the 4 to the 2 true, which is Boolean. What if I set this to false, by the way? Yeah, the answer should be 4, right? Yep. And you can see this type here is a integer. Okay. So we have a few more ways to explicitly typecast. You have ints, right? So this int, whatever the value is not an int, it'll convert it to a integer value. You have also float. Okay, so what if I have 4.22 as a string? Can I typecast that 4.22 to a integer? Yes. No. Okay. So it says invalid literal for integer with base 10. Right? So you can't try to typecast a float value to a integer. So you need to change from a integer value here and typecast it to a float because the string looks like a float. So Python will pick that up. Okay, so now it's 4.22 and the class is a float. So you need this float one here. Can I typecast a list from another value? So what if I need a list? Okay. Okay, so let's say I have these values here and I want to make them a list. What if I need a list of the Boolean and the string? So I would say my list. Well, let me see here. So to make the list, you have to wrap the list with those variables. Okay. So let's say I have this value here. Let's say I have this list here, 2, 3, 4. Okay. We have some list equal 2, 3, 4. Or some tuple. Let's say I have it as a tuple. That's probably a case. And you know, tuples have that non-mutable, right? So it's immutable property on the tuple. And I want to convert this tuple. Let's change this from some list to some tuple. I'm kind of going off the top here, you know. So let's try to convert this to some list here. We would have to do a list call, and then we could provide some underscore tuple to the list call. So you converted the tuple into a list. Okay. So if we print some list, some underscore list, and we print the type of some underscore list, we should be getting a list, right? So we now have the tuple being converted to a list, and we have the class as a list. Okay. You could have let's say we have this string here. Let's say we have some string. Let's call this str here. And we have 2. Okay. We have a string called 2, 3, 4. Okay, and we need to convert that string into a list. So some list string, or string of lists, right? So string, some list of strings, some string list, right? Okay. So now we'll need the list call here and put some string in there. Okay, and then instead of the sum list, we'll do some string list, and then set this to some string list. Okay. All right. So now it converted this string into a list, right? And it kept the white spaces. So if we didn't have these white space and it was a number, it was a string with a number in there, it would have changed each value of that string into a list index, into a element in one of the index of the list. Okay, so it converts the string into a list. What if instead of a string, this was a integer value? And we did the same list, right? So we have some int and we need the same string list here. We get error, right? So it says, oh, so this would be some int here. Okay. So that's line 13, some int here. Okay, int object. Okay, so here's the issue here. Int object is not iterable. Okay, so if we want to make this int object into a list, into a list here, we might want to do a string conversion, right? Or we could have wrapped it in the string conversion, and we'll get that list again. Okay, so and the same goes for tuple, right? So that's implicit and explicit typecasting in Python. Okay, and the reason for this is we could have functions and we've got some values as input, and we might have to there may be cases where we're adding different data types, right? And we need to output a certain data type. So because of that, we have this typecasting, right? First, we have to know implicit typecasting because that's the default that the interpreter falls back on. And then we have to know explicit because then maybe we want this type of data type, right, as a return from the function. Okay, so that's implicit and explicit typecasting. So that concludes typecasting in Python. The next step we have is operators in Python. So these operators are arithmetic, assignment, comparison, logical, identity, membership, bitwise, unary, right? So that's on one, ternary operators. So these are all the operators in Python. And just to note, these operators creates operations, and these operations create algorithms. So if you've ever heard of the word algorithm, it's a function, really, right? So it's a step-by-step way of coming to your desired output, right? So usually you could create a flowchart for your algorithm, or you could have pseudocoding, right? Or you could have different state in your algorithm as well, right? So these, again, operators, along with data types, create your algorithms, okay? So the next video, I'll cover operators in Python, and we'll see how these data types and these operators work in these different categories of operators in Python. Okay, thank you again for listening. Thank you.